Who remembers with forms of energy there were five different kinds of energy, different forms of energy that we talked about. And to remember them, we use the word melts. MELT and S. Who can remember, who can tell me what was one form of energy that we talked about yesterday? Jada, you said you knew one. What's one form of energy that we talked about yesterday? We had five. We had the M, the L, the E, the L, the T, and the S. So you're right. One of the forms of energy we talked about was electrical energy. That was our E. We still have an M, an L, a T, and an S. Violet, what was another form of energy we talked about?
Mechanical.
Mechanical. People moving their arms and legs, or machines with parts that are moving. Okay, so there's our M. So we had our M and our E. We still need the L, the T, and the S. Alexa.
Thermal energy.
Thermal energy, so things that get hot, or if you're taking away thermal energy, things that get cold. We still have the L and the S. What are those two forms of energy that we still have left? Noah? What's one of them?
Light energy.
Light energy, ones that we can see. So light energy, there's one last form of energy. So we've talked about mechanical, about electrical, about light, about thermal, and there's one last one. Jaylene, what was that one last form of energy?
Sound.
Sound energy, very good. Sound energy was the one that we can't see, but it travels in waves through the air and it goes into our ear. That way we are able to hear. So we're gonna watch this video talking about different kinds of energy. Since we're gonna watch a video, make sure that your microphone is off. Make sure that your camera is off. That way we can all see the video and hear the video clearly. Make sure your microphone's off. Make sure your camera is off.
Okay, just relax and keep your eye on the target. Well, that was closer than last time. Dear Tim and Moby, what is energy? From Lily. Energy is what makes matter move or change. It's the ability to do work. When the bow is stretched like that, it has potential or stored energy. We know that as soon as Moby releases the bow, that stored energy will be released as motion. The potential energy will transfer to the arrow. The arrow moving through the air has kinetic energy.
Okay, so when they talk about energy, sometimes they'll call it potential or kinetic energy. Potential energy is, I guess you could say, it's like stored energy. Not like the kind of energy that we store in a battery, but they gave us a really good example. They used a bow and arrow. So when he's pulling back on the bow and arrow, he's pulling that string, it has potential energy. He has to work, he has to pull back on that bowstring. And if you've never ever used a bow and arrow, you might think, oh, it's really easy, you're just pulling on a string. But you have to pull pretty hard to pull back a bow. It's not as easy as you would think. You actually have to try very hard. So you're storing a lot of that energy. You're using mechanical energy. You're moving your arms back, you're using your muscles, and you're storing all of that energy into that string. When you let go, like he does here, all that energy that was stored and saved in that string changes from being in the string to being in the arrow as it starts to fly through the air. Whenever you have energy that's moving things that are moving, we call that we say that they have kinetic energy. That just means that it's something that is moving. So, for instance, if you've ever had, or if you do have, like Hot Wheels toys, and sometimes they have like racetracks for the Hot Wheels toys. Sometimes they have like a hill that the car will start on. When you take the Hot Wheels car and you move it up the hill to the top, that's potential energy. You had to move it up to the very, very top, and when you let it go, that potential energy turns into kinetic energy. You see the car go down the hill and starts going around the turns or around the loop-de-loop, whatever is on the course.
Energy will transfer to the arrow. The arrow moving through the air has kinetic energy. That's the energy of motion. Not bad, you hit the target this time. Well, the bow does work on the arrow when you release it, and the arrow does work on the target when it hits. Energy comes in a bunch of different forms. There's chemical energy stored in food that your body uses to walk, run, and lift things.
So chemical energy is the kind of energy that I guess you could say that we run on. So we don't run on batteries, on electrical. We don't run on light energy. We can't just go outside and stand in the sun and feel full. We don't run on mechanical energy. We use it when we're lifting things or pushing things or running, but we don't have a wind up in our back that someone has to go and turn the key or the knob so that we can wake up in the mornings or so we can run around. We use chemical energy. When we eat, all that food that goes into our bellies, we break it down in our stomach, and that's where we get our energy from.
Power plants and batteries provide us with electrical energy.
We talked about those yesterday. Electrical energy can come from batteries, like these ones here, or from a power plant. Yesterday we said they were like big buildings, and they are. They can be pretty big because they have to make or provide electrical energy for a lot of people. It's not just for one neighborhood or even one house. It's for entire cities or big chunks of the city. So they're usually pretty big buildings. And there's different ways that they can make that electrical energy, but they all usually involve some sort of generator or turbine. So something that has to spin around and around. And as it spins, that's what creates that electrical energy.
The sun is our major source of light energy. Wind, moving water, airplanes, and sound waves all have mechanical energy.
Okay, before we go on to that mechanical, that is a big important thing to realize and to remember. So light energy, we thought of like light bulbs and lamps and flashlights and stuff like that. But the sun is where we get most of our light energy in the world. So when we're inside, we might have a light on or a lamp on or something like that. And when it gets dark, of course, we use flashlights or we have the lights on in our room or something like that. But for the most part, the light energy that we get comes from the sun. During the daytime, if we have a window open, we don't always need to have a light on in our room. Or if we're walking around during the middle of the day, we don't need to have a flashlight with us because the sun gives us enough light to see.
Wind, moving water, airplanes, and sound waves all have mechanical energy.
Again, mechanical energy is moving parts. So, and something like these wind turbines here, they have all those gears, all the parts on the inside that are turning, that are spinning around as the wind goes. Same thing with the airplane. You can see right underneath the wings here, this gray part where they have the engines. Those have a lot of different parts that have to be turning and spinning so the airplane can fly.
Vibrating atoms cause heat, and that makes thermal energy.
Okay, thermal energy. We talked about this yesterday. You can either add thermal energy and make something hotter, like in this case in the oven. And when you heat up your oven and you put your food in there, your cookies or whatever you're going to eat, it's adding that thermal energy into your food so that way it can get cooked. Or if you're talking about, like, let's say ice cream or something like that, or popsicles, you'd put them in the freezer or the refrigerator if it's leftover food, and the refrigerator or the freezer sucks out or takes away that thermal energy to make it colder.
Nuclear energy is released from inside atoms when they are broken apart or fused together.
So this is one of the ways that we can make electrical energy is with nuclear energy. Like they showed us, little teeny tiny atoms, when they break apart or when you stick them together, they release energy, and we can use that to help us make electricity.
Energy is released from inside atoms when they are broken apart or fused together. Nice shot. Hey, you're becoming a pro at this. No way. There's no way I'm letting you shoot this apple off my head. Forget it.
All right, we can go ahead and turn our cameras back on. We're going to go to our classwork. The topic we're looking for is science. And we have an assignment here at the top. It says forms of energy quiz. So it's got some questions about energy that we're going to answer. I want you to find that. Again, it's going to be in classwork. The topic we're looking for is science. The assignment says forms of energy quiz. Click on it. It'll take us to the quiz. It's going to look like this. It has 10 questions. We're going to read the questions, read the answer choices, and all you have to do is pick the best one. Okay? This is going to be about different kinds of energy or about different situations. So some of these you're going to have to think a bit about. Okay? Question number 1. What is energy? Choose the best answer. So we have 4 choices. Anything that radiates light or heat. Anything that travels in the form of waves. Any object in motion. Or anything that makes matter move or change. Yes, Kylie?
Where did we go?
We go into classwork. Our topic is science. And we're looking for forms of energy quiz.
Okay.
Okay. Question number 2. Which of these objects has kinetic energy? Yes, Kaylee.
Where is it?
Again, it's going to be in classwork. Your topic is science. Your assignment is forms of energy quiz. Which of these objects has kinetic energy? A ball moving through the air. B, a ball sitting on a table. C, a ball buried underground. Or D, a ball sitting on the edge of a cliff. Number 3, and for this one you have to read the answer choices carefully. What is the difference between kinetic and potential energy? Answer choice A. Potential energy is the energy of objects at rest, which means not moving. Kinetic energy is the energy of objects in motion. Answer choice B. Kinetic energy is the energy of objects at rest, which again means staying still, not moving. Potential energy is the energy of objects in motion. Yes, Violet.
Did you read number 1?
Yep.
Can you read that again, please?
Once I finish with this one.
Okay.
Thank you.
Answer choice C. Potential energy has to do with chemistry. Kinetic energy has to do with physics. Or answer choice D. Kinetic energy has to do with chemistry. Potential energy has to do with physics. So again, for that one, make sure that you read the answer choices very carefully when you pick one. because you don't want to pick the wrong one. Question number 1 says, what is energy? Choose the best answer. Anything that radiates light or heat, anything that travels in the form of waves, any object in motion, or anything that makes matter move or change. Yes, Alexa.
May you read question 4 again, please?
Well, 4 I haven't read yet, but I'm about to.
Oh, okay.
Question 4. Which of the following objects has the most potential energy? A ball sitting on a table. B, a ball resting on the ground. C, a ball sitting on a mountaintop. Or D, a ball that's been thrown into the air. Which of the following objects has the most potential energy? We have to choose which one has the most potential energy. Question 5. Which of the following terms has the same meaning as potential energy? So something that has the same meaning as potential energy. Stored energy, motion energy, light energy, or kinetic energy. Which of those things means the same as potential energy? Number 6. An oven produces what kind of energy? An oven produces, and that means makes, an oven makes what kind of energy? Sound, mechanical, heat, or kinetic? What kind of energy does an oven make? Yes, Alexa.
May you read question 5 again, please?
Question 5. Which of the following terms has the same meaning as potential energy? So they want to know which one means the same thing.
Okay, thank you.
Stored energy, motion energy, light energy, or kinetic energy? Question 7. What is the primary source of all light energy on Earth? The primary source means where do we get most of our light energy? Doesn't mean the only source, not the only place we get light from, but where do we get most of our light from on Earth? Is it lightning, volcanoes, the moon, or the sun? Where do we get most of our light energy from on the sun? Or sorry, not on the sun, on the Earth. Question number 8. Question number 8. What kind of energy does your phone use? So what kind of energy does your phone use? Does it use sound energy, light energy, mechanical energy, or electrical energy? Number 9. A TV can produce, it can make all of these kinds of energy Except what? So a TV, like we saw yesterday, it can make more than one kind of energy. What's the one kind that it can't make? Light energy, electrical energy, heat energy, or sound energy? What is the one kind of energy that a TV cannot make? Yes, Alexa.
What question are we on?
Well, I just finished reading number 9.
Okay, thank you.
And question number 10. What is not a kind of energy? So we talked about the 5 different kinds. Which one is not a kind of energy? Thermal, sound, lightning, or mechanical? Which one of those is not one of the forms of energy? Are there any questions that anyone needs me to go back and read for them? Okay. Once you've answered all the questions, and again, make sure that you put an answer for every single one, go ahead and press submit and turn in your work.